Okay, problem 5. Problem 5. We have use a method of undetermined coefficients or variation of parameters to find the general solution to the following neighborhood for the following non-homogeneous second-order ODE. Okay, first, what is homogeneous and non-homogeneous second-order ODE? For example, if this is y second derivative minus 2y first derivative minus 3y, okay, is equal to 0, as long as you see the 0 is on the right-hand side. And on the left-hand side, it's second derivative, first derivative, and y, okay, and they are linearly combined, then it is called a homogeneous. Okay, it's called a homogeneous second-order ODE. So what is a non-homogeneous? So the left-hand side, it's the same. But the right-hand side now, instead of 0, you have a function of x. For example, x plus 2. Right? This is called a non-homogeneous. Okay, this is called a non-homogeneous second-order ODE. Right? So how do we solve? How do we get a general solution of this? Okay, in problem 4, we already know how do we solve this type of question. Okay, but what about a non-homogeneous second-order ODE? So there are two parts. Okay, the general solution. Okay, eventually the general solution will look like this. Will look like YH plus YP. Okay, this is going to be, okay, let's call this equation equation 1. Okay, let's call this equation equation 2. Okay, this y is going to be the general solution of equation 2. Okay, and what is this YH? YH is a general solution of equation 1. Okay, and what is YP? YP is a particular solution of equation 2. Okay, so as you can see, to find the general solution of equation 2, you have to find the general solution of equation 1, as well as a particular solution of equation 2. Okay, so this part is actually covered in problem 4, right? How do we get YH? So how do we solve second order derivative minus 2, first order derivative minus 3, y is equal to 0? How do you solve this one? You can get its characteristic equation first. The second order derivative is lambda square, right? And first order derivative is just lambda. And y itself is just a constant. So it's lambda square minus 2 lambda minus 3 is 0. So lambda minus 3, lambda plus 1 is 0. So lambda is 3 or negative 1. Okay, so what is the general solution? Because now we have two different real solutions of the characteristic equation, right? We have two different real solutions. So the pattern of the solution would be a times e to the power of lambda 1x, which is 3x, plus b times e to the power of lambda 2x, which is negative x. Okay? So this a and b, they are arbitrary constants. Okay, a and b, they are arbitrary constants. So this is the first part. We've got our YH. Okay, we've got our YH. So what about the second part? How do we find a particular solution? Right, to find a particular solution, let's write down the equation 2 here. Now the left-hand side is the same. The right-hand side now it's x, right? What is the right-hand side? It's x plus 2, okay? So here we can just use the undetermined coefficients because the right-hand side is a first order, it's a power 1 polynomial, okay? It's a power 1 polynomial. So we can assume that this particular solution will also be a power 1 polynomial, okay? So let's call it Cx plus D. Right, so this follows the form of the right-hand side. Because here it is a power 1 polynomial, so here, your particular solution, we expect it to look the same. Okay, then all you need to do is to differentiate it. So it's C, and then differentiate it again. Right? You differentiate a constant, it will be 0. Right? Then sub in. If you sub in, it will be 0 minus 2 times C minus 3 Cx plus D is equal to x plus 2. Right, then you organize everything, so it's negative 3cx minus 2c minus 3d is equal to x plus 2. Okay, so it's clear that, for example, the coefficients of x should be the same on both sides. Right, so this, on the left-hand side, the coefficient of x is negative 3c. On the right-hand side, it's 1. So negative 3c is equal to 1. And the constant should be the same on both sides. Right, here this is a constant, this is a constant. So negative 2c minus 3d is equal to 2. So solve it, c is negative 1 over 3. D is, right, what is d? D is negative 4 over 9. Okay. Do you have any questions so far? Okay, so our particular solution, we found it. It's negative 1 over 3x minus 4 over 9. Okay. This is not the only solution. Okay, this is not the only solution of the second equation, but it is a particular solution of the second equation. Okay, so now you find your YH, you find your YP, then the general solution Y is just YH plus YP. Right, you just copy everything down. So YH is AE 3x plus BE negative x. Okay, then plus YP. YP is minus x over 3 minus 4 over 9. Okay, so this is your final answer. Okay. Part B. Part B is y second derivative minus 4y's first derivative, right? Minus 12y is e to the power of 6x. Okay, again, the general solution of this equation, okay, let's call it equation 2, right? And its corresponding homogeneous equation is whatever on the left doesn't change, right? And you change the right-hand side to 0. Okay, so then the general solution of the second, should I change there? I think it's okay. So this is a homogeneous, this is a non-homogeneous. So the general solution of the second equation is the general solution of the first equation, right, plus the particular solution of the second equation. Okay, by first, I mean this one. By second, I mean this one. Okay. Then again, how do you get YH? To get YH, you need to get the general solution of this homogeneous second order, which is doing, just using the characteristic equation, right? Lambda squared minus 4 lambda minus 12 is 0, so lambda, okay, minus 6 times lambda plus 2 is 0, which means lambda 1 is 6, lambda 2 is negative 2. Okay. So the general solution for the homogeneous equation is a e to the power of 6x plus b e to the power of negative 2x. Right. So that's the first part. That's the YH. So to get YP, just write down this non-homogeneous. Right? Let's just write down this non-homogeneous. Again, we can use undetermined parameter method. So we can assume that the particular solution looks like, because now the right-hand side is e to the power of 6x. Right? Since it's e to the power of 6x, so the particular solution will be just e to the power of 6x times a constant, right? Times a constant. But here's a problem. You can see this particular solution. Right? Just call this constant C. You can see this particular solution is already part of the general solution of the homogeneous equation, right? It's e to the power of 6x, it's e to the power of 6x. So whatever, no matter how you solve it, it's already included in the homogeneous general solution. Okay, so that's why we have to do something like this, right? Yes, times x. Okay, you just need to time the whole thing by x. Okay, and this will be the particular solution for the non-homogeneous. So again, to get the constant c, you just have to get the derivative. So now the calculation is much more complicated. Let's do it down here. Okay, so the first order derivative, you have to use the product rule, right? Remember, u times v's derivative is u's derivative times v plus u times v's derivative. So here it's c times, okay, x derivative is 1 times e to the power of 6x plus x times, so e to the power of 6x, its derivative is 6e to the power of 6x. Okay, so you summarize it, it's c simplified e to the power of 6x plus x e to the power of 6x. Okay. Wait, there's a 6, right? Yeah. Yes, and then the second order derivative, just differentiate this again. So it's c times the first part, e to the power of 6x, you differentiate it, it's just 6e to the power of 6x. And then the second part, again, so it's 6 times, okay, so you do the same thing. It's 1 times e to the power of 6x plus x times 6e to the power of 6x. Okay. Okay, so it's going to be 12c e to the power of 6x times 3x plus 1. Okay. And here, this part, you can just simplify it as c e to the power of 6x, 6x plus 1. Right. So then just sub everything back to this equation. Right. So yp, okay, just yp, you put it here, and then y's derivative, you put it here, and y second order derivative, you put it here. Okay, so you have to do this. A lot of calculation, but you have to just do it. Okay, this is the second order derivative minus 4 times the first order derivative, which is 4c e to the power 6x, 6x plus 1, right, minus 12y, y is just cx e to the power 6x, is equal to e to the power 6x. Okay, now simplify everything, right, so I can remove the 6x, e to the power 6x, okay, so it's c is a common factor on the left, so it's c times like 36x plus 12 minus c times like 24x plus 1, okay, minus just c times 12x is equal to 1, okay. So here you just cancel out e to the power 6x, and you also like, it's c times, you know, a polynomial. Yes. Yeah. Yes. Okay, then just have to solve it. So you can see here 36x, right, minus 24x minus 12x. So actually these three parts, they disappear, right? So it's just 12c minus 4c is equal to 1, so c must be 1/8. Okay. Then the particular solution, after all the calculations, is just 1/8 x e to the power 6x. Okay. Then the final solution, y, is just yh plus yp, which is a e to the power negative 2x plus b e to the power 6x plus 1/8 x e to the power 6x. Okay. So again, same steps to solve the question, just the calculation is more complicated. Okay. And for the third question, part C, we're not going to use undetermined coefficients to get yp. We're going to use the variation of parameters. Okay, so let's solve part C. Part C, this is the equation. Okay, again, y is equal to yh plus yp. So what is yh? Yh, you just need to solve y second derivative plus y is equal to 0. Okay, just solve this, which is the characteristic equation, lambda squared plus 1 is equal to 0. Lambda is positive or negative I. Okay, so here you have two complex numbers as a solution of the quadratic equation. So what is yh? Okay, so what is yh? Yh now, okay, it's going to be, so even if it's just positive or negative I, right, the real part of this complex number is 0. So it's 0 plus or minus positive or negative I. So it's a e to the power of 0x, right, sine, right, and here I, it's I times 1, right, so it's times sine 1 times x, okay, plus b e to the power of 0x cosine 1 times x. Right? So simplify it, right? E to the power of 0x is just 1, and right, so it's just a sine x plus b cosine x. Okay, this is yh. This is yh. Right. Then, how do you get a particular solution? Okay, see here, for the method of undetermined coefficients, we actually don't have anything for tangent x. Okay, for sine x, for cosine x, we can use the undetermined coefficient method. But for tangent x, we really we really don't have any, anything. So here we have to use another method to find YP, which is called the variation of parameters. Okay, we have to use variation of parameters to find YP. Okay, how do you find YP? You should start from the YH. So YH is A sine X plus B cosine X. Okay, so you can call this first part sine X, you can call this Y1, and then you can call this part Y2. Okay, then first we can find the Wronskian, right? Find the Wronskian, which is a function of Y1 and Y2. So the Wronskian of Y1 and Y2, it is a determinant of Y1, Y2, Y1's derivative, Y2's derivative. Okay, so let's do it. Y1 sine X, Y2 cosine X. So what is sine X derivative? Cosine X. Right? What is cosine X derivative? Yes, negative sine X. So, and what is a determinant? This determinant thing is just this diagonal product minus this diagonal's product. Okay, so which is sine times negative sine minus cosine times cosine. So it's negative sine squared minus cosine squared, which is negative 1. Okay, which is negative 1. Okay, now we can get the particular solution. So before getting the particular solution, we still have to do two things. First, it's an integration of y2 times rx. Okay, so y2 we know it's cosine x, right? So what exactly is rx? So rx is this right-hand side. So this tangent x in this right non-homogeneous second-order ODE, this is your rx. Okay, so your rx is just this right-hand side thing. So it's just tangent x over the w you just get. Right, over the w you just got. So it's over w y1, y2. Okay, dx. So y2 is cosine. Rx is tangent over 1. Sorry, over negative 1. Okay. Then because your tangent is what? Your tangent is sine over cosine. Right? So cosine times tangent is exactly just sine. So it's negative, you just integrate sine. Okay? So integrate sine, you get negative cosine with a negative sign in front. So it's just cosine. Okay. Normally we will write down cosine x plus c, right? But here for using the variation of parameters, we just ignore this constant part. Okay, we don't have to plus c here. Similarly, you have to do y1 times rx over w y1 y2. Okay. So what is y1? y1 is sine x, rx is still tangent x over negative 1. Okay, this is more complicated. So first, I don't want to work with tangent x, I want to work with sine or cosine. So I can write it as just sine over cosine. Right, which means on the top is just sine x squared. Okay, now I still don't have any clue how to integrate this part. But we know that sine x, right, sine x squared plus cosine x squared, it is 1. So it's negative 1 minus cosine x squared. over cosine x. Okay, dx. So it's negative 1 over cosine x, right, plus just cosine x. Okay, because this over this is just 1 over cosine x with a negative sign in front. This over this is cosine x, 2 negative signs. Right. Then you integrate it. It should be much easier, right? Here you are integrating 1 over cosine x is secant x, right? And here this cosine x thing, the integral is sine x. Okay, so how do you integrate secant x? Right? There's actually a formula for the integration of secant x. It's just the lowering absolute value of secant x plus tangent x. Okay, this is a formula for the integral of secant x, then plus sine x. Okay, so all the calculation we've done, we've got this, right, we've got this. So now we can finally write down our particular solution. So yp, the formula for yp is negative y1 times this first integration we just calculated, right? It's the first integration we just calculated plus y2 times the second integration we just calculated. Okay, which is y1 sine x. Right, what's the first integration we calculated? It's cosine x. Right, so just drag it down. Sine x, cosine x. y2 is cosine x. Then this integration is this. Right? The integral is negative ln secant plus tangent plus sine. Okay, so I don't want to simplify this. I'll just leave it as this. Then our final answer is y is equal to yh plus yp. Okay, I don't want to copy it again. So this is it. Very complicated, but essentially it's just some integration, right? You can see, I think the formula, you should definitely write it down, formula sheet. Okay, but there's actually nothing more than just some integration and differentiation. Okay, even if it looks very complicated. Okay.